Welcome, everyone. I hope you can hear me now. We've encountered some technical difficulties, which seems to be par for the course these days with all of our Teams meetings and Zoom meetings and all of that. Give us just a moment here and we'll go ahead and get started. But I did want to let you know that we are proceeding. So bear with us one moment and we'll be starting the presentation. Welcome, everyone. If you're just joining us, thank you for attending. And I just wanted to welcome you to the CDFA Healthy Soils Week celebration and to the Natural Resources Conservation Service presentation on getting NRCS soils information. Our presenter today is Tony Rolfes, the NRCS California State Soil Scientist in the Davis State Office. And my name is Sheryl Feit, and I'm the State Resources Inventory Coordinator for NRCS California, also based in Davis. First of all, we'd like to thank Joyce Mansfield and the other folks at CDFA, along with the participating partners, for their hard work to make this virtual event a success. It's been going on all week. There's been multiple webinars, there's been a Twitter storm, and it's been a lot of fun. I know that our own Public Affairs Department has been working very hard. Christine, thank you so much for managing our Twitter feed. It's been really neat to watch all the interactions going on. And I want to encourage everyone to visit our NRCS Healthy Soils Week webpage. We have a dedicated webpage for the event. And here you can find videos of growers sharing their soil health stories, links to soil health resources, and other soils information. You can find the link to the NRCS website in the presentation announcements over on the right, but I'll explain how to find that in just a moment. And tomorrow, December 5th, is the internationally recognized World Soil Day. This is its 6th year, and the theme for 2020 is Keep Soil Alive, Protect Soil Biodiversity. Okay, let's see. It looks like we have a nice group today. We have about 25 attendees, so thank you everyone for joining in. We encourage you to participate and ask any questions that you might have, though we might need to hold off on the answers until the end in order to save time. Just depends on how many questions we have. But before we start, I thought I'd give you a quick rundown on how to ask those questions for those who may be new to Microsoft Teams. If you look in the upper right corner of your Teams screen, you'll see a little icon containing a question mark just to the right of the Leave button. When you click that button, the Q&A panel will open up on the right. To ask a question, enter your name and your question at the bottom of that panel. Any questions you ask will appear in the My Questions tab that's located near the top. And to view everybody else's questions as well as the announcements, just select the Featured tab. So with that, I'm going to hand it on over to Tony.
Hey, good morning, everyone. Sorry for the technical difficulties today, but we're going forward. Anyway, again, thanks for joining, and happy Healthy Soils Week. In collaboration with CDFA, we are providing this webinar. And as Sheryl said, it's World Soils Day tomorrow, December 5th, 2020. And I've been working in soils for over 35 years, and it hasn't been until the last 5 years, since 2015, International Year of Soil, that soils have been getting some notoriety. So as a soil scientist, I'm so appreciative of that. We are getting that, finally getting some respect. Anyway, today's webinar, I'm going to talk about learning how to find NRCS soils information. So I'll give you a little background on the soil survey program first, and then how we conduct the soil surveys, because I think that's important to understanding what data is in our database. I'll talk about how to find the soil survey information, and then I'll talk about some of the other soil survey applications that we have. And then I'll go back to Sheryl, because she, in her former life, she was a conservationist planner, so she'll talk a little about our NRCS conservation programs. I'll go ahead and get started. So if you see this map, it's, as I said, we have soils information throughout the United States. If you look at each of these little squares on the map, that's basically a county, and every one of those has a soil survey. About 95% of the nation counties have been mapped, and there's information provided for those surveys. We've been doing the soil survey program from 1899 to today, so we are literally as old as dirt. And in the nation, we have 3,265 soil surveys covering the whole nation. In California, we have 121 surveys. And if you look at this map, you can see all the green areas. Those counties are available on Web Soil Survey and other applications to get the information. The yellow areas are in progress, and the orange are not in progress at this time, but this is mostly BLM land in the Mojave Desert. So again, 120 surveys in California, a lot of surveys to manage. We've also identified 2,870 different soil types or soil series in California. And we identify those based on different layers and textures, colors, organic carbon, and all those different soil properties. And I'll talk about that a little bit more later. In the United States, we've identified over 20,000 soil series or soil types, a lot of them out there. We have a state soil, which is called the San Joaquin Soil Series. If you look at the map on the left, you can see the extent of San Joaquin. There's about 450,000 acres of that soil mapped. And if you notice, it's mostly on the east side of the Sacramento River and the east side of the San Joaquin River. That's important because the material that it formed in is alluvium out of the Sierra Nevada. And the Sierra Nevada is mostly made up of granitics. So if you look at the soil profile, think about the alluvium of fine-grade granitics that the soil formed in, and this soil has been forming for over 500,000 years to almost 1 million years, depending on the surface. You can see the surface layer is fairly light colored, not a lot of organic carbon in that. Then you have the B horizon, which has a clay texture. It's weathered over that 500,000 years to form a B horizon of clay. Notice this light colored horizon. That's what we call a durapan. I talked about the granitics out of the Sierra. Granitics have a lot of quartz, and what's quartz made up of? Silica. So as the soil weathered in that 500,000 years, pushed the silica down to this layer, which is at about 20 inches. It ranges from 20 to 40 inches, and that created a hard pan. It's very hard. So this is your state soil. It has a hard pan. San Joaquin. Okay, so I think it's important to understand how we get the information. So how do we collect the soil information? Well, we actually go out and dig holes, many of them, and a typical soil scientist would map anywhere from 30,000 acres a year to maybe well over that, depending on the complexity of the land. And the kind of things that we gather when we're out there are the different layers, horizons, the color, the texture, depth, rock fragments, organic matter, the chemistry, pH, salts, and SAR. But we also get information about the landform, like the vegetation, the slope. Is it on a toe slope? Is it concave, convex, or is it flat? So we gather all that information. One of the big questions I get is, how many holes do you dig? And the answer to that is, it depends. Yes, it depends. And the one thing you want to do is do as few holes as possible and use your brain and not your back, and try to figure that out based on soil forming factors in the landscape. So if you look at this landscape, this is near Winters, California. You look at the mountains in the background, foothills in the middle, and the valley bottom in the foreground. Think about that and how you would separate that out. This is what a soil scientist would do. They'd first think about, well, look at the 5 soil forming factors. Look at climate. Look at the mountains in the very back. Precip there is going to be much higher. Vegetation is forest, opposed to grassland in the foothills, and crop in the valley bottom. Think about the parent material. Sedimentary rock in the coast range, alluvium and sedimentary rock on the foot slopes, and definitely all alluvium in the valley bottom. Think about the time we talked about San Joaquin being 500,000 years old. The mountain slope being very steep, those soils don't stay in place very long, so they're very young. Whereas this terrace here, that soil is going to be probably hundreds of thousands of years old, so it has a lot of time to develop. Whereas the valley bottom, depending how close you are to Puda Creek, the further away you get from that, the older. So you're probably looking at tens to hundreds of thousands of years old on the valley bottom too. Think about topography, if it's concave, convex, where it's located on toe slope, ridge, those kind of things are important to soil development. So all those things the soil scientists are thinking about when they're partitioning out the landscape. Here's what it looks like, the same area. Here's the valley we were looking at, here's the foothills, and you have the mountains as well. Look how the soil scientists partitioned out all the soil types. And each one of these soil types has a map unit symbol. This one's SH. That refers to the soil type. So yeah, San Ysidro loam, 0 to 5% slopes. You can also see within there, there's 8% inclusions of Solano and Rincon, but most of it is made up of the San Ysidro. These are the profile for that series. You have an AP horizon A, BT, BT1, BT2, BT3, BT4, and all the layers. So this is the typical profile of the San Ysidro loam. One piece of information I can get you about the data is the organic carbon. This is the organic carbon by depth. It's about 1 organic carbon at the down to about 36 centimeters. When you get down to 71 centimeters, it goes less than 0.2%. So that's how the map is made. These are the map unit polygons. Map unit symbol relates to information. Okay, so how do you get the information? Most of you probably, I think, would have used Web Soil Survey at one time, but I'm not sure if you're proficient at it. I'm going to go through that. So if you search the web for Web Soil Survey and hit that link, this is the first page that will come up. Web Soil Survey page. There's also a number of other links here, like the Geospatial Data Gateway. That's where NRCS houses all of our geospatial data. Things like census data, digital elevation models, climate data, all sorts of data at this point. Also, this is where you can get to Web Soil Survey and our Soil Survey data. And also, many of you probably have used our old manuscripts, which we don't produce anymore. Those hard paper manuscripts that are maybe anywhere from 1 inch to 6 inches thick, these huge things. We don't produce those anymore because everything is online and digital. But you can go to this Archive Soil Survey link to download those original manuscripts from anywhere from 1960s and to today. Okay, so what I'm going to do, and here's how you do it, is you'd start Web Soil Survey by this obviously green button. So we'll do that. When you first start Web Soil Survey, this is the map you're going to get. Like I said, we have soil surveys throughout the United States. So, and what you'll see are these tabs up here. This is important to look at these. These are the tabs we'll be using: the area of interest, soil map, soil data explorer, download soils data, and shopping cart. So remember those. We won't download soils today, but you can download that from this site for a county or for a specific area of interest, a small area, even 20 acres. And you can use that in ArcMap or GIS, but we won't do that today. So the first thing I want to do is come over this panel, and this will also be very important, the navigation and search panel. First thing I want to do is find my area that I want to find the soils information, and you can do that by address. You can do it by state and county. You can do it by soil survey area. You can do it by latitude or longitude, public land survey, or any of these federal land areas. I'm going to go with address. So I click on that. I pre-entered this address, Consilla Lane, Winters, California. I hit view, and this is what comes up. This is the UC Davis Russell Ranch between Davis and Winters. Pinpoints this area. So at that point, I want to define my area of interest, and area of interest is the area that you want to get your soil map and your soil information. So you have these tabs up here. You know what these are: zoom in, zoom out, pan, go back a screen, identifier, ruler, measure. But I want to look at these two here. Area of interest. These are the choices you can define your area of interest. This one's irregular, where I could go around and do different points and make an irregular shape, but I'm going to use the rectangular area of interest. So I'll click on that, and I put an area of interest around this zone. You can see the blue hatched zone. That's where I'm going to get my soils information and soil reports, soil data for that zone. You can look over in this panel, and I actually hit 2 counties, Solano County and Yolo. Solano is down below Puda Creek, and Yolo is above Puda Creek. It actually gives me the acres of each one within that area of interest. So there's 58 acres in Solano and 757 acres in Yolo. So I've got my area of interest, and now I want to get the soils map. So I go back up to these tabs. These are the critical tabs you're going to be working with. I'll hit soil map, and there you go. Instantaneously creates the soil map for that area. Check out here again, you have the polygons of each of the soil types. So look at this one, BRA, that's Brentwood Silty Clay Loam 0 to 2%. That's a map unit name, symbol, and it gives you the acres in the area of interest and also the percent of the area of interest. If you go down to Solano County, you can see YO. Up here, that's YOLO loam 0 to 4% slopes. It gives you the acres and the percent in the area of interest. So I've got the soil map, and here's where I want to add that to the shopping cart. So you add that, you click on shopping cart, because at the end we're going to show a report that you generated, and you need to do that for each one of these products that we develop here. So the next thing I want to do is go to this tab up here again, Soil Data Explorer. That's where I get the data about the soil map. So I'm going to hit that, Soil Data Explorer, and notice these tabs that come up down here. So you get new tabs, you got these above, and you have the new tabs down here, and you have Intro to Soils, which is a good read. If you want to look at that, you can add that to your report. Suitabilities and limitations, soil properties, and soil reports. So I'm going to go through these 3 and show you how that is done. So my first one I clicked on is suitabilities and limitations. And see, these are the kind of ratings you can get. You can get building site development, construction materials, disaster recovery planning, land classifications, hydric soil rating, which relates to wetlands, irrigated capability class, which relates to cropland suitability, and so on. You have quite a few things you can get for ratings. I chose land classification. You can see it's highlighted here by using this drop arrow. And there you can get the California Revised Story Index, conservation tree and shrub groups, ecological site ID, and so on. But I chose farmland class, and you can see it's highlighted. So I'm going to get the farmland class for this soil map by just hitting View Rating. Voila, there you go. There is the rating and a map of prime farmlands. So if you look at this legend, which to get that you have to hit the legend button, and you get prime farmland. Most of it is prime. It's good soils out there. That's probably why they chose that for the UC Davis Russell Ranch Experiment Farm. Good choice, UC Davis. But you can also see there are some that are not prime farmland, and that's along Puda Creek, which is river wash, and then I know this area over here is a steeper slope, so it doesn't make prime. So I can scroll down, and you see here it also gets you a tabular or narrative look at these map units. It gives you the map unit symbol, the map unit name, and it tells you if it's prime, not prime, prime farmland. Gives you the area of acres in the area of interest and the area percent in the area of interest. I'm going to hit shopping cart again, click on shopping cart because I want that report to be in my final product. And now we're going to go to soil properties and qualities. The last one was for ratings on different uses. This one is on soil properties like chemistry and physical properties. So I'm going to hit that one. And this screen comes up. Again, you're going to be using the screen on the left, and it gives you ability to get soil chemical properties, erosion factors, soil health, which is a good one for Healthy Soils Week and World Soils Day, physical soil properties and soil qualities and features and water features. I'm going to choose chemical soil properties. So I do the drop-down box, and you can see that I could either get calcium carbonate, cation exchange capacity, CEC, electrical conductivity, gypsum, or pH. I chose pH. because I want to see what the pH of these soils out here are in this map. So I hit view rating, and again, the map pops up with the different pHs for each of those map units. So if you look at the legend, this area is moderately alkaline. The lighter green is slightly alkaline. We have neutral, and we have moderately acid in there. Those are the pHs of those map units, and that's the dominant component in those map units. So I'm going to scroll down again, and again, it gives it to you in a narrative or tabular format. Again, the map unit symbol, the map unit name, and again, the rating, pH of 6.7, 7.4, 7.5, and so on. It gives you a description as well of what we're doing there. So I'm going to go ahead and hit shopping cart again. Boom. That'll add this report to our final report. Don't forget the shopping cart. Now I'm going to do the final one, soil reports. So again, I hit that, and you get a different legend over here. I can do area of interest, disaster recovery, land classification, land management, soil chemical properties, soil health properties, which is appropriate for today's, soil physical properties, soil qualities and features. So you have a number of reports. These are different than the other two. They're different than soil properties or suitabilities and limitations in that these are reports and they don't create maps. And I'll show you that in a minute. So I'm going to view the soil health report called organic matter depletion, salt concentration, aerobic soil organisms, and organic soil subsidence. That is the report I'm going to look at by hitting view soil report. And this is a report you'll get. And the reason why we don't get a map with that is because there's actually 4 different types of information you're getting. It's not just one like pH or one like organic matter, you're getting 4. So it can't create a map on that. We have all of these we're looking at. And the organic matter depletion for this soil map unit, Rincon, OM depletion moderately high. So that means organic matter depletes or oxidizes fairly high in that soil. And it gives you the reasons why, because it's well aerated, moderate moisture deficit, and those kind of things. So I'll scroll down one more time. And it gives you the actual description of why about the organic matter depletion in these other categories. For instance, here it says the ratings for soil organic matter depletion are based on seasonal saturation, organic matter content, clay content, and shape of the land surface. All those are important to how the organic matter depletes. And so again, for this one, it's moderately high depletion rate. Okay, so I've gone through all of the different tabs here to get the reports, suitabilities and ratings, soil properties like pH, and then reports, which are a narrative report. Each time I hit add, I'm going to hit it for this one too to make sure that is added to the shopping cart. So I click that. So I've got everything I want. I mean, I could add so many other reports I wanted. If you wanted to, you can do as much as you want. And then I'm going to hit shopping cart. Boom. And this is what comes up when you do shopping cart. So over here, you can put a custom title, which I did, Healthy Soils Week 2020. You can do some map scales and printing things, and then you can create this table of contents, which is all pretty much already done for me, so I'm not going to touch that. And then I go to checkout. It's just kind of like Amazon, right? Just online shopping. So do this as much as you like, and it's free. That's the better part. You don't have to pay a thing for this. And when you do checkout, you get these options. You get it now or download later. I'm going to get it now, so I'll do go OK. Voila, you get a PDF instantaneously that you just created in this this web soil survey and shopping cart. This report that I created, I'm only showing 2 pages, but the report I created had actually 47 pages. It's quite a professional looking document. You can provide to your neighbors. They'll be pretty impressed on your ability to create a soils report. This is basically a custom soil survey manuscript. So you can see here, this is the area of interest that we created, the Russell Ranch right there. Custom soil resource report, Healthy Soils Week, that's my title I put on it. If you look on the left, look at the table of contents, We put the soil map in there. Remember, we added that to the shopping cart. We did the land classification, farmland classification. We added that. We added soil properties of pH. All those were put into the table of contents. The other one that was added that we didn't have to add, which automatically comes in, is the map unit description. This is a detailed map unit description, and these are, I think, one of the best reports that we have in here, because I'll go through it just a little bit so you see what's on there. Again, you have the map unit symbol, the name, Brentwood silty clay loam, 0 to 2% slopes. It gives you the setting. Mean annual precip is 12 to 20. That's the range where the soil is mapped. Also, the range of elevation is 50 to 400 feet. Mean annual temperature range, frost-free period, and this one is prime farmland. It tells you that right there. If you go down to the setting, remember I talked about when we map the soils, we record different things about the landform. So this was formed on alluvial fans. It's in the position is the toe slope. Landform position, 3-dimensional is base slope, and it's linear. It's not concave or convex. It's a linear slope, so fairly flat. It gives you the typical profile. So 3 layers on this one. 0 to 10 inches is a silty clay loam, and so on. It's all silty clay loam, so it's a pretty good texture, pretty good soil. Slope, it's deeper than 80 inches, so no restrictive feature. Well drained, medium runoff. Okay, and this is the KSAT, or how water moves through the profile. At KSAT, or permeability, saturated flow, important for how you irrigate or septic tanks suitability. So it's 0.2 to 0.57 inches per hour. That's how water moves through that soil. Depth to water table greater than 80 inches, so it's not poorly drained. No flooding, no ponding, very little salts, 0 to 2.4 millimoles per centimeter. And then look at this one, available water capacity, 10.8 inches. That is tremendous amount of water holding capacity. That's to a depth of 60 inches. So again, Russell Ranch, they picked a good soil because it does hold a lot of water. And it gives you the minor components. Let's see, it gives the land capability class as well of 1. That's the best one we have in the US or California, land capability class 1. You can see the irrigated class is 4C. Well, we are a dry state. Without the Sierra Nevada bringing water into us, we would not have very good land capability classes, because without irrigation, we go down to a 4 class. Hydric soil group, C. Hydric rating, no. So no potential to be a wetland in that area. So this is the detailed map unit description. This is one of the best reports I think that I like. So you'll get that automatically when you create your report in the shopping cart on Web Soil Survey. So that's the report you'll get. I just wanted to go over a few other things that we have. So if you Google or search, shouldn't support Google, NRCS soils data and maps. If you do that, hit the link, you're going to get this page. This is a great page because it gives you links to many things that we have. Gridded soil survey. So if you want to get a map using a GIS, ArcMap, you want to do it for the whole state and you want to get pH across the state, that's the greatest tool. It's a gridded soil survey. It's a raster-based map. You use it in an ArcMap, and it's for the whole state of California. So I can do pH or salts or what have you, building site development for the whole state of California in one fell swoop in ArcMap. You can also do it for the whole United States. So if you go to the gateway, geospatial gateway, you can download that, what we call gridded soil survey, or GSurgo. You can download that, or also there's the, GSurgo, and that also has, you can choose between the whole United States, or you can choose just for California, or any state for that matter. A great tool if you need help. Sheryl later will talk about all the access to help for this from a resource soil scientist and me. You can call me directly as well. We talked about, the geospatial gateway. Okay, one last thing I want to talk about is the PEDON map and data. This is a cool site everybody can access interactively. I'll click on that. This map appears. This is an interactive website. Every one of these points on here, it represents a detailed soil characterization that our soil scientists dug a pit, usually a backhoe, sometimes by hand, but they dug a pit down to at least 70 inches, sampled each horizon, packed them up, sent them to our Lincoln lab in Lincoln, Nebraska. They did a total characterization of the soil sample. The yellow ones represent samples that they did geochemical data as well, and the purple ones are just our basic soil characterization samples. So I'm going to zoom in on California, and you can see Sacramento here. You can see Fairfield, Vacaville, Elk Grove. I'm going to choose this point right here, and this is all interactive. You can do this online, just like I'm doing here. I'm going to choose this one. This is very close to the UC Davis Russell Ranch, so I'll click on that, and this appears. And you can see again that the series is the YOLO series. There's a number of reports you can get: primary lab report, supplementary lab report, water retention report, a number of things. But I'm going to go to the primary lab report. This is hyperlinked. Click on that, and this report automatically comes up. I know it looks pretty daunting, but I'll just show you a few key things on here. Here again is the YOLO series, gives you the taxonomic classification. This one was done in 1983, but we have over 4,000 samples in this repository in California. That's just in California. They're taken anywhere from the 1960s to currently. Our soil scientists are still gathering samples right now, so I'm sure we have some from this year as well. But over 4,000 samples in there, which is very good baseline data. So just look at a few things. You have all the layers, the designation horizons, the depths in centimeters, and the textures. You have the total sand, silt, and clay. It gives you that information for that site. It breaks up the textures: silt, fine and coarse silt, sands, very fine through very coarse, and it gives you the rock fragments. Also gives you bulk density, oven dry bulk density for each layer. This is the one I like to come to because I use this quite often, because with soil health and everybody wants to know what the baseline carbon is, soil carbon is. So this is very useful. That this one is 1.41 soil organic carbon for the surface layer. Now this is what you're going to be tested on. If you want to convert that to percent organic matter, multiplied times 1.72. So you have organic carbon is 1.41. You want to convert that to soil organic matter percent, multiply that times 1.72. What's that come up to? 2.5. So it's got 0.5% organic matter in this soil YOLO at that spot. That's pretty high again. Again, good thing UC Davis got that, because for California Central Valley, 2.5 is fairly high. Okay, coming to the end, and this is the last thing I want to do is give a shout out for UC Davis California Soil Resource Lab, and that's run by Dr. Toby O'Gene. Dr. Toby O'Gene is our NRCS Soil Survey Cooperator Liaison in California, and him and his students at this lab do a lot of cool tools. They've done all these, and they're continually working on it. He's working on things right now with his students. One that you've probably used, and I think one of the best ones I've seen in the over 35 years I've been doing soil survey, is this soil web app for your phone. And because this is GPS orientated, you can go out in the field anywhere you are, click this link as long as you're getting connectivity, and you can find the soil where you're standing. So I think that's one of the best tools we've had. So you can go to this site too, just by Googling UC Davis Soil Web App. All right, so now I'm going to turn it over to Sheryl, and she's going to talk about some of our programs. And take it away, Sheryl.
All right, thank you, Tony. Before we move on to the questions, I do want to give a brief overview of the Natural Resources Conservation Service and the assistance we offer. NRCS is an agency within the USDA dedicated to helping America's farmers, ranchers, and forest landowners conserve our soil, water, and other natural resources. All of our programs are voluntary, and they offer science-based solutions that benefit both the landowner and the environment. We work with both small and large acreage landowners, as well as tribal governments and nonprofit organizations. NRCS provides both technical and financial assistance in a variety of conservation programs, including our I always stumble over this, Environmental Quality Incentives Program, also known as EQIP, in which we provide assistance for conservation practices, including assistance for soil health practices. So if you are interested in planting cover crop or you want to learn more about reduced tillage, contact us because we can both give you advice as well as perhaps give you some financial assistance. Our Conservation Stewardship Program, CSP, is for those growers who would like to take their conservation practices to the next level. We also have our Agricultural Conservation Easement Program, ACEP. This is for landowners who are seeking to place wetlands, ag lands, grasslands, and forests under long-term easements. And then last but not least, we also offer our Regional Conservation Partnership Program, also known as RCPP. This is done on a region-wide basis, and it competitively awards funds to conservation projects that are designed by local partners specifically for their region. Eligible partners include private companies, universities, nonprofit organizations, local and tribal governments, and others joining with ag and conservation groups. And in addition to our conservation planning programs, we also offer post-fire disaster assistance. NRCS California has local offices covering all 58 counties in the state. You can visit our website to find the office nearest you. You can find the link for our offices near the top of the Q&A panel, along with our Healthy Soils Week webpage. And that link is not for the offices, it's for our main website. So if you go to the main website for NRCS, then you can find your county and the office that services you. For specific soils information, you can contact our area resource soil scientist for your county. In Area 1, which is the blue part of the map in Northern California, that is Jackie Vega in the Red Bluff office, and you can see her phone numbers up there on the screen. Area 2, which is the coastal region in green, is handled by Phil Smith in the Salinas office. Area 3, which is the Central Valley in orange there on the map, that is handled by Luis Alvarez in Fresno. And Area 4, which is the Southern California and desert region in purple, you can reach out to Peter Faunestock in Victorville. And of course, you can always contact Tony, our state soil scientist in Davis. Well, that wraps up our presentation, but I think we still have time to answer questions. If you have any questions, please enter them into the Q&A over in the right. And as I mentioned earlier in the presentation, you can find the button to open that is up at the top next to the leave button. It has a little question mark on it. Just click in it, enter your question in. Be sure to put your name right above your question. There's a little space for it. And we'd be happy to answer any questions you may have on Web Soil Survey, on NRCS programs, on Healthy Soils Week. Let us know what you need and we'll be happy to answer them.
You can give it a minute, Cheryl, and see if we get any questions.
Yeah, we'll give it a minute. I think Tony did such a great job with his presentation that people are going to go out and use Web Soil Survey right now. They don't need any extra help. All right. Let's see here. I do have a question. Tony, the link that you, or the slide that you were showing where they can, it was near the end. It had the map of the US and it had the, where you can go find information. Let's see if you go back. Yeah, right there below the NCCS, the NCSS, that area. Yes. Do you have the link for that? Is that something that you can post in the announcements, or that I could post in the announcements?
We could. Again, you could just Google or search. I hate to support Google so much, but search for NRCS. Always put that in front. NRCS Soil Survey Lab Data. That'll get you there. It's the Kellogg, or you could do NRCS Kellogg Lab Data. It'll get you there. Or you can go to that page before this page and Google NRCS Soil Data and Maps. Hit that link, NRCS Soil Data and Maps. Search for that, and you can go to this will come up, and you can go to PennAm Map and Data. Click on that, and it'll take you to this map right here. So multiple ways. But anything you do with NRCS, it comes up first, Web Soil Survey or what have you. Just always put NRCS Soil Survey, NRCS lab data, anything like that, and we'll get you there.
Great. All right. Oh, let's see. Okay, here's a good question for us. What role does plant species play in determining the number of corings and soil mapping unit contours?
Okay, yeah, definitely plants are one of the key indicators of how soils change. I definitely use that as an indicator when you change. Like for instance, I can go back to my examples and more mapping I did in Montana than I have anywhere else. So there, I mean, typical example is when Idaho fescue came in, that automatically told me I was at a 15-inch precip zone. Below that would be a different zone, and you would change soil types just based on that plant type. Also, when big sagebrush would come in, that also indicates a different soil type. So you're always keen on the plant type, vegetation to determine when that soil changes. But you have to look at so many things, the 5 soil forming factors, to make those predictions and check and thinking about that as you map the soil. So there's a lot going on in your head when you're mapping, and plants are definitely one of the main key indicators when the soil map unit or soil type will change.
All right. Well, that looks like that's the last of our questions. So be sure to check out NRCS and our Healthy Soils Week webpage via the links at the top of the Q&A panel. Oh, let's see. Wait, we've got one more that came in. What role does plant species play? Oh, we just had that. Oh, okay. How much confidence do you have in the soil chemistry values in surveys done decades ago?
Well, soils don't change, right? I mean, like I say, they don't change that quickly, except on the surface. Maybe the top 6 to 8 inches where we've been manipulating those, if we have been in farming, you know, pH, the SAR and those kind of things could change with management. But for the most part, if you think about the soils below 10 inches, that does not change that readily or that quickly. And even the pH, you know, that's going to fluctuate. So you want to test at the time if you're doing some recommendations, but it's going to give you a baseline. I mean, certain soils aren't going to change that much. Organic carbon, the same thing in the surface. You know, with a lot of manipulation, it could decrease the soil carbon, or with a lot of cover crops and compost, you can increase it. I've seen that happen. But the most organic carbon is somewhat recalcitrant. There's a lot of it that's held that way, but then there's the other ones, another type of carbon, the more younger pool can fluctuate. But overall, the soils don't change that much, except maybe the surfaces. So you want to check that surface layer for any of those changes. Hope that answers your question.
All right, that looks like that's it. One last thing, remember tomorrow is World Soil Day. And with that in mind, the next time you're walking across your farm or your garden or even your lawn, remember there's a whole world in the soil beneath your feet. Let's all do a better job of taking care of it, and it will help take care of us. Thank you for attending. Have a really great rest of your day. Bye.
Bye-bye. Thank you.